Hello and welcome. So, we're going to be answering a question which is in the figure below. We have two triangles. Triangle ABC is similar to triangle DEF. A little squiggle means similar right there. Okay, and then we're told that D and E are lying with on AB, right? And that just means that don't assume that D and E are on AB, but we're actually told that while it looks like they're on the line, they actually are. Okay, now we're told that given B to E, which is that segment right there, is congruent to A to D, meaning that whatever this segment is, this segment has to be the exact same thing. Okay? And those two segments are congruent to each other, and the other lengths and the figure below, so we're given 29 and 145. Okay, what is the length of A to D? So, that length, end goal. So, when we're looking at this one, there's a couple ways we could set this up. Similar triangles mean what it is by definition is that you have between your triangles this proportionality, meaning that if you multiply 29 by some number in order to get to 145, which is going to be whatever 145 divided by 29 is, okay, that number is going to be the same proportion where you would have to multiply 13 by that same number in order to get to this whole side, right? Whatever this side was, you'd have to multiply it by that same number to get to that side. And that is what it means to have proportions, equal proportions on all sides. In other words, similar triangles. So there's a couple ways we could do this, all right? We could write in a actual equation for this thing, because we know that if we have 145 over 29, that proportion has to be the same thing as whatever this entire side is over 13, because you have two triangles right here. Here's your small triangle versus here is the big triangle, right? So you're always going, here we did 145 over 29, which means we're doing large to the small. Okay, which means we should say large value over small value. Keep it consistent on the other side of your equal sign for your other proportion. So it's all right, well, what's the entire side here? Well, we know 13 is going to be a part of it because we can see 13 there. We have three portions of this side. We have portion 1, 13, and portion 2. Oh, we already know that's 13, and we know that because we're told that these two sections are congruent to each other, whatever that is, this has to be the same number. Well, what happens if we add all of those together? We get 13 plus 2 x's. Whatever that x value is, that's the value we actually need to find. Okay, because that's the length of AD. So then, you have an equation. Solve for it. You multiply both sides by 29, because then that removes the 29 on this side. And then we'll have that times 29, 13 plus 2x. You could also multiply by 13 on the same step, because that'll wipe out the 13s and leave all of your fractions gone. So then you're just left with 145 times 13, which is 1,885, equals 29 to the 13 plus 2x in parentheses. So we can distribute that through. So I'd say 29 times 13 is going to leave us 377. Whoops, as my 7 looks a little wink there. Plus 29 times 2, which is going to be 58x. And if we want to solve this equation, subtract the 377 to the other side. So then we have, let me write that out. 1,508 equals 58x. Undo the multiplication by division. So from there, you would divide both sides by 58 and leaves with just the x. So x is then 1508 divided by 58, or in other words, 26 is our remaining side. Okay? And then that means that 26 is your x value, which we know is going to be both of these. We set it up that way. Bam. Okay, another way that we could have done this is without setting up an equation at all. We could have instead said, oh look, if we do 145 divided by 29, Alright, we get 5 from that. I didn't realize it simplified up there. Oh, details. It's fine. Okay, 145 over 29 equals 5. That means that whatever we have on this side, multiply it by 5, you get the larger triangle. So if we know, let me just clear a lot of my writing on this thing. If we know that if we multiply the small side by 5, we get the entire thing, well, 13 times 5 is 65. That means that the entire side, this entire side, has to be 65. Because we know that that's the proportion, is that multiply by 5, we get to the whole thing. And if we know that that's made up by 2 equal portions, all we do is take out the 13 from the 65. We don't care about that. We're trying to find the little portions, so 65 minus 13, that gives us 52, and that means that our 2x portions must be the 52, and then that means our x has to be, from there, 26, because that is splitting the 52 equally between 2 of those sides, and then that adds up to 65. Okay, that's another way you could have done it. Either or works. Okay, those are both same ways to go about the same problem. Different ways to go about the same problem. Alrighty, thanks for watching.